let's practice what we just learned about those sets of real numbers. Let's take each of these real numbers and put it in this diagram so that it captures what kind of number it is. Okay, so the number 6 to start off with, the number 6 is, it's a real number. And first we can decide whether it's irrational or rational. So remember that irrational numbers always have non-terminating, non-repeating decimals. Well, 6 doesn't have that. So that immediately means that it's rational. Okay, is it an integer? Yes, it's an integer, right? It does not have a denominator that's not equal to 1. Okay, is it a whole number? It is a whole number because it's positive. Okay, is it a natural number? Yes, it is a natural number because it is something that it's a number that we use to count with. So in the natural number set, we can put in that 6. That's where it belongs. Okay, so we've got that one. Let's just cross it off. 2.73. We have a decimal now. So that is not a natural number. It's not a whole number. It's not an integer. It terminates. It does not have a dot, dot, dot after that 3. So it means that there are no other decimal places. So it is a rational number. Okay, we got that one. All right, what about 3/7? Well, 3/7 is written as an integer in the numerator over an integer in the denominator. That's the definition of a rational number. If we plug that into our calculator, we would find out that it was repeating. So 3 divided by 7 is 0.42857142857. So 3/7 goes in rational number, but it's not an integer or whole number or natural number. Okay, next one, square root of 6. So here the key is you can plug that into your calculator to see what happens with the decimal if you're curious, but remember that anytime we take a square root of a non-perfect square, it's going to be irrational. If you plug that into your calculator, you're just going to get this long list of numbers after the decimal, and there's no pattern. It doesn't terminate. So square root 6 goes in there. All right, what about square root of 9? Well, square root of 9 is a perfect square, so square root of 9 is a 3. So it's not irrational, right? It does not have non-terminating, non-repeating decimals after the decimal place. So it's rational. It's an integer. And because it's positive, it's a whole number and a natural number. So, oops, let's get rid of that. Errant, there we go. That is in here, all right? That's the square root of 9, which is 3. All right, so we got that one. Now what about a negative 100? So negative 100 it's not irrational, so that means it's rational. It has denominator of 1, so that means it's an integer. It's negative, so it's not a whole number or a natural number. So negative 100 goes in this circle for integers. So also shows that it's rational, but also shows it's not whole or natural. Okay, 0.0. Well, 0.0 is not irrational. And so that means it's rational. It is an integer and it is a whole number. So we can put that in here as a whole number. So it's an integer, but it's not a natural number, right? Not one that we use to count with. What about 2 pi over 3? Well, because of that pi, which is irrational, that means that 2 pi over 3 is also irrational. So 2 pi over 3 goes in our irrational set. Now, the next one is 0.36 repeating. So that means it's 0.36, 36, 36, and then it just keeps going like that. Well, in our definition of rational numbers, we said that we could have rational numbers that repeat, and the block that repeats is that 36. So that goes in here as rational. Negative 1/2. So that's a number that is written as a fraction of two integers, 1 and 2. That is rational. So negative 1/2 goes in there. So let's see, we got those two, and negative 38. So it is not a fraction or a decimal, but it is negative. So that means it goes in here as an integer. Because it's negative, but it is not a fraction or decimal, it is an integer. Okay, so you're going to find problems like this on your first XYZ homework assignment. The first few problems ask you to identify different types of numbers. So this will be good practice to get you ready for that assignment.